Alright, so today we are going to be looking at lesson 22-1. So this is going to be looking at the trig ratios. And so we're going to be doing a little bit before we even get to those. We are not going to look at lesson 22-1 this year. We are skipping it so that we can try and catch up a little bit due to all of our COVID closures. So we were dealing with, if we had looked at the lesson 22-1 yesterday, some similar triangles. And so this group that they have here are three of the triangles that we would have looked at yesterday, and we were supposed to figure out that they were similar. So that's what we looked at yesterday, had we done that lesson. In each of the triangles, they give you an L, an S, and an H. So on this one, L is 8, S is 6, and H is 10. That's your longer side, your shorter side, and your hypotenuse. So your longer side is this vertical side, 8. Your shorter side is the 6. If you can't tell, you can also just count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And then your hypotenuse is 10. Likewise, on this middle triangle, the vertical side is the long side, 4. The base is 3. And the hypotenuse is 5. And then on this last one, the vertical side is 12, the base is 9, and the hypotenuse is 15. So they want us to fill out this chart. They give us some ratios. The length of the opposite leg, the length of the hypotenuse, adjacent leg. If you don't know where to start with this, if you're like, I don't even know what opposite and adjacent and hypotenuse mean. So let's look at one triangle. Let's look at angle A here. In this triangle, where is the hypotenuse? Well, the hypotenuse is across from the right angle. So our hypotenuse is the 10. Then, once we have labeled the hypotenuse, what is the other side that is next to the angle A? The 10 was adjacent to it. It was next to it. So the other side that is adjacent to angle A is the 6. So this is our adjacent side. Leaving the 8 as the last one, which is the opposite. It is across from the A. So that's why it is opposite. So now, looking at our first box, the length of the opposite leg over the hypotenuse. So we labeled the opposite is 8, and our hypotenuse is 10. 8 over 10 reduces to 4 over 5. The length of the adjacent leg, our adjacent is 6, our hypotenuse is 10. So we have 6 over 10, which is going to reduce to 3 over 5. And then for the last one, the opposite is 8, and the adjacent is 6. And so we have 4 over 3. Now you don't have to label opposite, adjacent, and hypotenuse. If you can look at it and tell what's the opposite and the adjacent and the hypotenuse, that's fine. So if you look at this second triangle, we have angle C. So opposite is the 4, and the hypotenuse is 5. So 4 over 5. For this next one, adjacent and hypotenuse. The adjacent is 3, and our hypotenuse is 5. So we have 3 over 5. And then for the opposite over adjacent, we have 4 over 3. And so some of you may be picking up on a pattern. Some of you may not yet, and that's okay if you don't see it. But let's see if you are seeing a pattern, if it holds true for this last one. Our opposite is 12, and our hypotenuse is 15. So 12 over 15 reduces to 4 over 5. Our adjacent and our hypotenuse are 9 and 15. And 9 over 15 reduces to 3 over 5. Then going to our opposite and our adjacent. The opposite is 12. Adjacent is 9, and that reduces to 4 over 3. And we're going to come back to that pattern of why are they all the same? But how are they connected? We know these are similar triangles, so the ratios of their sides should be the same. So let's look here. For each of the triangles that we were just using, we want to use the protractor to find the measure of the larger acute angle. So I want to go back. Which of these angles is bigger? We'll look at this one. Is this angle E bigger or is this angle up here larger? And the clue, you may be able to tell based on the angles themselves, but the clue is the opposite sides. So 9 is opposite this angle. 12 is opposite this angle. Which of those numbers is larger? The 9 is smaller. 12 is the larger number. So 12 is the larger side compared to the two legs. So this angle is the larger of the two acute angles. So same way with all three of them. So we need to find the measure of angle A and C and E. And we're going to fill those in with our chart. So let's look. If you look at your book, the first thing you're going to want to do is to draw a line extending these sides. So we're going to go ahead and do it for all three of the sides. And then we can use our protractor, so you put your little hole on your protractor on the angle that you have. And then you line up the side with the base of the triangle, and then you look at your angle. So why is it not going to be 120 something? This is an acute angle, so we need to use the acute numbers, the smaller numbers. So if you look, you should get 53 using your protractor. Let's look at angle C. If you look, it is also 53 degrees. And then if you look at this one, it is also 53 degrees. So on our chart, we're going to put 53 degrees for each of those. So what we just found was that the measure of each of the three angles were the same. So in another right triangle, if we know the measure of the larger acute angle was the same as angle A, C, and E, so if it was also 53, what would you expect the following ratios to be? Well, hopefully, since we also have a right triangle and we have an angle that is the same, we noticed a pattern that the opposite over hypotenuse was always 4 over 5. So in another triangle that is still similar, we would expect that ratio to be the same. Then the length of the adjacent to the hypotenuse we found every time was 3 over 5. So we would expect that it would still stay as 3 over 5. And then the opposite over adjacent we found was 4 over 3. And so what did we do to find this? Well, we knew that one angle of a right triangle was 53 degrees. And we have a 90-degree angle because it's a right triangle. Which means the triangles are going to be similar because the ones in number 1 also have a 90-degree angle and a 53-degree angle. So the triangles are similar. And the reason they are similar is angle-angle similarity. And so that's how we know the ratios will be equal, because we have similar figures. We looked at that a few activities ago. So that leads us into this ratio of the lengths of two sides of a right triangle. When you set up these ratios of your side lengths, anytime you have a right triangle, that is called a trigonometric ratio. Some of you may be familiar with the word trigonometry. So related Trigonometry is a study of your trigonometric ratios. The basic ones that we are going to start with are sine, cosine, and tangent. Sine, cosine, and tangent. They are abbreviated as such, S-I-N, C-O-S, and T-A-N. But you still say them as sine, cosine, and tangent. You do not say sin, cos, and tan. They are still sine, cosine, and tangent. It's just writing them is a little bit shorter. So, where have you seen these before? Might have seen them on the ACT, questions you didn't know how to answer, or you might have seen them on your calculator. So, number 5 says, use a scientific or graphing calculator to evaluate each of these to the nearest tenth. So we're going to round to 1 decimal place. And it says, make sure your calculator is in degree mode. So what that means, let's look at how to actually do that with our calculator. So, first thing you want to do, if you look, your calculator is in degree. And you can check if you have one of these little blue calculators because it'll say degree. And so then you're going to, if it's not, you can clear your memory. So press and hold the on and the clear until it says memory cleared. And it'll revert back to the degrees. So look, right now it's not in degrees. But if I press and hold on and clear, it goes back to degrees. That's what its default is. And you want it to be in degrees. It doesn't change unless the buttons accidentally get pressed. So, first thing we're wanting to look for is the sine of 53. So, on your calculator, do you see the sine button? It's 2 above the 7. So, 7, go up 2, there's the sine. So, you're going to hit sine, and then it says 53. So, you're going to type in 5, 3. And then if you're not putting anything after it, you do not have to close your parentheses. And you can hit enter. And it says round to 1 decimal place. So what do you put? 0.8. Looking at the cosine, it's right next to the sine button. Cosine of 53 is 0.6. And the tangent of 53 is 1.3. So on these, your calculator should have given you the same thing that mine gave me. So on your quiz or your test, if you don't get the right answer, it's not because your calculator gave you the wrong answer. Your calculator is not a mind reader. Whatever you input is what it's going to spit back to you. So if you put in the cosine, the sine of 35, that's not the same thing as the sine of 53. So you've got to make sure that you input what you want it to find. It can't fix your mistakes. So if you don't do well because you don't use the calculator appropriately, you can't blame that on the calculator. That's your fault. That's a user error, not a calculator error. So let's write those on here, and then we'll go to number 6. In each column, from number 1, we had the same ratios. We want to write those ratios as decimal numbers. So, in the first column, we had 4 over 5. What is 4 divided by 5 as a decimal? 0.8. What is the second number that we had? It was 3 over 5. And what is 3 over 5 as a decimal? 0.6. What is the third column we had on our thing? We had 4 over 3. And what does that simplify to be? If you go to 1 decimal place, 1.3. So those are your numbers that we had looked at the original part, just in decimal form. And what do you notice? Do you notice you have some that are the same? Hopefully you do. And that's what the next part is leading us into. It says to compare your answers to what we had in 5 and 6, and then describe what might be the same. So this one says the length of the opposite side to the hypotenuse. So let's go back. Our opposite to our hypotenuse was 0.8. Which one of these gave us a 0.8? The sine. So the length of your opposite leg to the length of the hypotenuse is your sine ratio. And so the x is from this angle x that they said to use. You just put a variable. They said use x. If you don't like x, pick a different one. Then they're talking about adjacent to hypotenuse. So our adjacent to our hypotenuse was 0.6. Which one of these is 0.6? The cosine of 53. So this one is going to be the cosine, leaving tangent for the last one. These are your trig ratios. So I'm going to write them a little bit differently. I'm going to abbreviate. Instead of saying the length of opposite leg, as just opposite. And instead of the length of hypotenuse, just hypotenuse. HYP, OPP. Shorthand of those. For cosine, I can say adjacent, ABJ, over hypotenuse. And for tangent, I can say opposite over adjacent. So those are my ratios. These are imperative that you memorize them. It is imperative to learn these. If you do not memorize these, you're not going to be successful with these on your quiz or on your test. You've got to know them. So, a couple of different mnemonic devices. Mnemonic, it's a memory device. A memory device. It's something to help you remember these. So, first off, I'm going to just look at the first letter of each of these. Sine, opposite, and hypotenuse. Cosine, adjacent, and hypotenuse. And then tangent, opposite, and adjacent. And if you write those as sine is opposite over hypotenuse in one line, so go into each of these, and you say it SOHCAHTOA. That may be one way that you can remember it, is just remember the word SOHCAHTOA, or the sounds SOHCAHTOA, SOHCAHTOA. Those are the order. Another one that the book that I've used before used was Oscar had a hold on Arthur. And so it doesn't use the sine, the cosine, and the tangent. It just uses Oscar had a hold on Arthur. Another one, some of her children are having trouble over algebra. So that could be one. Or another one, some old hippie caught another hippie tripping on acid. Do I care which one you pick? No. But you've got to pick one, and you've got to memorize these. This is vital to being able to use the trig ratios. So, someone asked, does the order matter? Yes, absolutely. If you mix them all up, you're not going to be able to work through this. You've got to learn these in the proper order. So, let's look at actually applying them. So, number 8, it says, write the ratios in simplest form. So, we're going to start with this first column, sine A, cosine A, tangent A. So, if I'm looking at angle A, I know that the 17 is my hypotenuse. What is opposite of angle A? Not 15. Look. What is over here across from angle A? The 8. So, this is my opposite, and this is my adjacent. So then when I go to use my sine of angle A, sine is opposite over hypotenuse. So opposite is 8, hypotenuse is 17. So 8 over 17. For cosine, the cosine of angle A is going to be adjacent over hypotenuse. So adjacent is 15, hypotenuse is 17. So we have adjacent over hypotenuse, 15 over 17. Then for tangent, opposite over adjacent. Opposite is 8, adjacent is 15. So that's how one way that you can actually use your trig ratios. We'll get into, over the next few lessons, other ways to use them. So now let's look at C. So here is angle C. My hypotenuse is still here. It's like that on both. But what is opposite angle C? Not the 8. So this is no longer the adjacent. This is the opposite. And the 8 is the adjacent. Notice the opposite and the adjacent switch when you're looking at different angles. So you have to be very careful that you're paying attention to the proper angle when you're doing these. The angle switches around the opposite and the adjacent. So the sine of C, opposite over hypotenuse. Opposite is 15, hypotenuse is 17. Looking at the cosine of C, the opposite, it's adjacent over hypotenuse. The adjacent is 8, and the hypotenuse is 17. And then tangent is going to be 15 over 8. So if you don't know your trig ratios, it's going to be really hard to put the numbers in the correct places. So it asks us, how are the two acute angles of our triangle related? So that is looking at angle A and angle C. So first off, we know this is a triangle. What do we know about the three angles in a triangle? They all three add up to equal 180. But I already know angle B is 90 degrees. So what does that mean about the angle A and C? What do they add up to equal? Angle A and angle C are going to add up to equal 90 degrees. So how are they related? The word for that is complementary. So they are complementary. Then it says, what is the relationship between the sine and cosine of complementary angles? So looking up here, what do you notice about your sine and your cosine of angle A and C? Do you see how this 18 over 7 and this is, 8 over 17 and this is 8 over 17? These are the same. The sine of angle A is the same as the cosine of angle C. Same thing here. The cosine of angle A is equal to the sine of angle C. They're both 15 over 17. And that's always going to be the case. So what's the relationship? The sine of one angle is equal to the cosine of the other angle. So anytime that you have complementary angles, their sine and cosines are equal to each other. So let's apply that on part D. If you know that sine of 68 is 0.93, what angle is complementary to 68? 68 plus what angle equals 90 degrees? 22. So what we know, what trig ratio we know, is something about 22. And it's still going to be 0.93. So the sine and the cosine. So if I have sine here, I'm going to put cosine with 22 degrees. So if the sine of 68 is 0.93, the cosine of the complementary angle is also 0.93. So some of you may be good with that. Let's look at one more. I'm going to try and do that with a different number. 30 degrees. If I say the sine of 30 degrees, that means that the cosine of 60 degrees is the same. Or let's say I take the cosine of 55 degrees. Well, the sine, 55 from 90 minus 55 is 35. So the sine of 35 would be the same. Your angles, what's important, your angles have to add up to 90 degrees. Those add up to 90 degrees. Okay? So now let's look at the next page. Check your understanding. If you can, try these by yourself and then unpause the video and listen to what I have to say on these. So for number 9, triangle ABC is a 30, 60, 90 triangle. Explain how to write at sine of 30 as a ratio without knowing the lengths of any side of a triangle. So I know in my 30, 60, 90 triangle that all of the sides are in a ratio of x to x times square root of 3, or 1, and then 1 times square root of 3, because remember your short side, you multiply it by square root of 3 to get your longer side, and then you take your short side and you multiply it by 2 to get your hypotenuse. For any triangle, they're always in that ratio. Then, if you look at the 30-degree angle here, opposite over hypotenuse is what sine is. So opposite the 30 is the 1, and the hypotenuse is 2. So that's in simplest form, 1 over 2. Every time the sine of a 30-degree angle is going to be 1/2. Every single time. Let's look at number 10. Suppose you know that triangle RST is a right triangle. So R is the right angle, and then we have S and T. So what do we know about angle S and angle T here? We know that they're complementary. S plus T is going to be 90 degrees, the measure of those angles. They're going to equal 90 degrees. So they're complementary. So if I know that the cosine of S is a number, the sine of angle T will also equal that same number. Looking at number 11. We have a right triangle, and it tells us C is the right angle, and we have A and B. And it's not drawn to scale, and that's okay. They tell us the sine of angle B is 5 over 13. So we know sine is opposite over hypotenuse. So what that means, our opposite is 5. So the side opposite to B is 5. And our hypotenuse is 13. So determine the length of the missing side. We're going to use Pythagorean theorem here. So 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. And if you subtract 25, you get 144. And so take the square root. And so your missing side is 12. So I'm going to fill in a 12 here. Then I can determine the cosine of angle B. So cosine is adjacent over hypotenuse. So adjacent to angle B is the 12, and our hypotenuse is 13. So the cosine of angle B is 12 over 13. For part C, the tangent. Tangent is opposite over adjacent. So opposite is 5, and the adjacent is 12. So now let's look at some of the practice questions. We want to use a calculator to find each of the following and round them to the nearest hundredth. So let's look at how to use the calculator here. We're going to use sine of 48. So you're going to go to your calculator, make sure it's in degree, sine of 48. And so rounding to 2 decimal places, because that's the nearest hundredth, we would say 0.74. For tangent of 65, I get 2.14. The next one is cosine of 12. And so I get 0.98, 0.98. And sine of 90 is 1. So that's how you can use your calculator. Again, if you don't get that, you're doing something wrong. Your calculator is not the one messing up. So now let's look at number 13. Write each ratio in simplest form. So the first thing you want to do is to use your mnemonic device to write your trig ratios. So if you want to use SOHCAHTOA, can do that, or if you want to say any of the other ones, you pick whatever you prefer. So the sine is the opposite over hypotenuse. So we're looking at angle x. So this says x right there. So the opposite is 36 over 45. And so 36 over 45 reduces to 4 over 5. Then the cosine of angle x is 27 over 45 because it's adjacent. The 27 is right next to this angle x. The reason we don't say the 45 is adjacent, the 45 is the hypotenuse. So 27 over 45 reduces to 3 over 5. Now let's look at the sine of y. The sine of y is opposite over hypotenuse. So opposite y is 27 over 45, which is 3 over 5. What do you see? Those are both 3 over 5. These are the same, and they should be, because x and y are complementary angles. So if you notice, sine of x and the cosine of y, x and y are complementary. So this cosine of y should also be 4 over 5. And let's check. Here's y. Adjacent is 36. Hypotenuse is 45. 36 over 45 reduces to 4 over 5. Now for the tangent. Tangent of x. Opposite of x is 36. Adjacent is 27. So we have 36 over 27, which is 4 over 3. And then tangent of y. Opposite is 27. Adjacent to y is 36. So that is 3 over 4. And those are reciprocals. Every time, if you have complementary angles, your tangent of them will be reciprocals. That's true. So now, looking at number 14. Elena was asked to write an explanation of how to find tangent P. She wrote, to find the tangent of angle P, I found the ratio of the length of the side opposite angle P to the length of the side adjacent to angle P. So is that correct? Is tangent opposite to adjacent? Opposite to adjacent? Yes. Since these sides have the same length, the tangent of angle P equals 1 foot. Critique her statement. Is there anything that she should have written differently? And if so, what? So the only issue is right here. The tangent of P equals a number, just 1. So she shouldn't have put the feet. So that's the only very small detail that she messed up on. So hopefully that helped you with understanding your trig ratios. The most important part of this lesson is that you learn your trig ratios. These. So you find a mnemonic device, a memory device. You need to learn it because in class you're going to have to tell me what it is on a quiz or on a test. You have to know your trig ratios to be able to apply them correctly.